This is section 5.1, Graphing Quadratic Functions. Our objective today is I can graph a quadratic function, and I can find the axis of symmetry, y-intercept, vertex, and maximum or minimum. Why do we care, and what is this used for? Quadratics are actually used for a lot of things, including finding out the way to make the maximum amount of profit in a business. And you can Google other ways if you'd like to see what else these are used for, but they do actually have a lot of uses. In a quadratic function, the greatest exponent is 2. These functions can have a quadratic term, a linear term, and a constant term. And there's a little chart showing you what these are going to be looking like. The graph of a quadratic function is called a parabola. Looking at example 1, we're going to graph a quadratic function by using a table. We'll be graphing f of x equals 3x squared minus 12x plus 6. Now, the integer values have already been given to us for the x value, so all we have to do is figure out the y values and figure out which points we're going to be graphing. So in our table, the values they gave us for x were 0, 1, 2, 3, and 4. So what I've done here is just gone through and plugged each value in to my equation for x. So on the first one I plugged in 0, on the second one I plugged in 1 for x, on the third one I plugged in 2 for x, and so on and so forth. So when I go ahead and evaluate these, I'm going to just do 0 squared, which is going to be 0. 0 times 3 is 0, minus 12 times 0, which would still be 0, and then 0 plus 6 is going to give me 6. So that's going to be able to find the y values, and we're going to do that on each one. And if we do that, we're going to get 6, negative 3, negative 6, negative 3, and 6. And so when I go to write my points, I'm going to write my x value, which in this case was 0, and then the y value that I got, which was 6. So 0, 6 is the point that I'm going to plot. In the second one, I'm going to plot 1, negative 3. In the third one, I'm going to plot 2, negative 6. In the next one, I'm going to plot 3, negative 3. And in the last one, my point is going to be 4, 6. So just going ahead and looking at what this is going to look like on a graph, I can go ahead and go from 0 up to 6 and make my point, and 1 down to negative 3, make my point, and 2 down to negative 6 and make my point, and 3 down to negative 3, make my point, and then 4 all the way up to 6 to make my point. And then we can go ahead and connect all of our lines, or all of our dots, with one smooth line, which is going to create a U shape or a parabola, which is what it should be since we're graphing quadratic functions. The axis of symmetry is a line through the graph of a parabola that divides the graph into two congruent halves. The axis of symmetry will intersect the parabola at one point only, and that's going to be called the vertex. Consider the graph y equals ax squared plus bx plus c, where a does not equal 0. The y-intercept is always going to be our c value, the value that doesn't have an x. The equation of the axis of symmetry we're going to use is x equals negative b over 2a, and the x-coordinate is going to be negative b over 2a. In example 2, we're looking for that axis of symmetry, y-intercept, and vertex. We're looking at the equation f of x equals x squared plus 4x minus 3. Remember, the y-intercept, which they're asking for in this case, is always going to be that c value. So for the y-intercept, we want to look and see what is that value that does not have an x. Now, some equations may not write it last, but if it's written in the correct notation, it will be last, but you always just want to look for the number that does not have the x value, which in this case is going to be the negative 3. So the y-intercept in this case is going to be negative 3. The equation of the axis of symmetry, remember, we're going to plug in our equation. I'm going to abbreviate this with AOS, and we're going to write x equals negative b, so remember our second value is our b value, so I'm just going to go ahead and actually write out what a, b, and c are in this case. A is going to be 1 because it's what's in front of the x squared. b is going to be 4 because it's what's in front of the x, and then my c value is just going to be negative 3. So if I go to plug these things in, I'm going to have negative b, which will be negative 4, over 2a. So our equation of axis of symmetry is x equals negative 4 over 2 times 1. And then that x coordinate is just going to be actually evaluating that. So we're going to have negative 4 divided by 2 times 1, or negative 4 divided by 2, which is going to be negative 2. In portion B, we're making a table of values that includes the vertex. So now you know exactly which x values to choose. In the first example, it was given to us, but in this one, we actually are going to choose our own x values. So the way that we're going to do this, we always want our middle value to be whatever we got for that x coordinate. So since we got negative 2 on that x coordinate, that's going to be the middle value of x that we choose. So negative 2 is our first x value, and then we just want to choose two values that are greater than negative 2 and two values that are less than negative 2. So I'm just going to choose negative 1 and 0, and then I'm going to choose negative 3 and negative 4. And you're going to see why it's so important that we choose that x coordinate as our first x value. So if we go ahead and do what we did in example 1, all I did here was go through and fill out our values here with where we're going to be plugging them in, and we're going to plug in each of our x values. On the left hand side, we're going to be plugging those in for the x values in the equation f of x. So once I go ahead and evaluate those, 0 squared is going to give me 0, plus 4 times 0, which is 0, so 0 plus 0 is 0, and then subtracting 3 will give me negative 3. Doing the next one, I'm going to get negative 6, then I'll get negative 7, then I'll get negative 6, and then I'll get negative 3. So this is where you can see the importance of choosing that negative 2 as your middle value. This is going to give you the very bottom or the very top. It's going to give you the vertex of our quadratic function, and then it's going to give you two nice values that you can graph on either side of it. So if we're going to write out our points, we're going to have 0, negative 3, negative 1, negative 6, negative 2, negative 7, negative 3, negative 6, and negative 4, negative 3. So if we were going to graph in this case, we would just graph each of those points on our graph. But this only wanted us to make a table of values that included the vertex, so we're going to stop there on this one. Maximum and minimum values. The y-coordinate of the vertex of a quadratic function is the maximum value or minimum value of the function. These values represent the greatest or lowest possible value the function can reach. And here you can see if the point is at the very bottom of the graph, it's going to be a minimum. If the point is at the very top of the graph, it's going to be a maximum. In example 3, we're going to be determining whether the function has a maximum or a minimum, and then we're going to actually be stating that maximum or minimum. So let's go ahead and look at this. We know that if a quadratic function starts with a negative out in the front, we know that the graph is going to go like this. Okay, so we know that based off of what this graph would look like, since it has a negative in the front, this value all the way up at the top is going to be a maximum. So we know that this particular function is going to have a maximum. And then we have to actually find out what that value is going to be. So the way we're going to do that is going to be the same way we find out that middle value for our table of values. So we're going to use negative b over 2a. So a in this case is negative 4, b is 12, and c is 18. So negative b is going to be negative 12 over 2a, so we'll have 2 times negative 4. So then we'll have negative 12 over negative 8. And if we go ahead and reduce that, we're going to have 3 over 2. But that's only for our x value. So I'm going to go ahead and write this down at the bottom. That is going to be the x value of that maximum or minimum, but we still need the y value. And the way we're going to do that is by plugging the 3 over 2 back into our equation. So we're going to have negative 4 times 3 over 2 squared plus 12 times 3 over 2 plus 18. Now, if I have 3 over 2 squared times negative 4, I'm going to end up with negative 9. And 12 times 3 over 2 is going to give me 18. And then we'll have our plus 18 on the end. So negative 9 plus 18 is going to give me 27, which is going to be the y value of our maximum in this case.